And let's zip through this. Okay, there's a bunch of questions on 2-4 like this, where they're going to give you some information, and you've got to come up with the equation of a line with that information. Now, it's always the same strategy. The information will be presented differently, and there's different little twists and tricks that can be applied in how you get the information, but you're always doing the same stuff. You're trying to come up with an equation ultimately that looks like this, that looks like y equals mx plus b. Okay? There's a couple ways we can get to that. Now, there's something on the assignment. There's some questions that ask you to use point-slope form. I used to be much more interested in having people do that than I am now, but I still want you to be exposed to it. Here's how we use this new form of a line called point-slope to do problems like this. But then I don't really care if you do it this way. You have to do it this way a couple times, but you don't have to do it this way very often. Point-slope looks like this. Point-slope form of a line looks like y minus y1 equals m times x minus x1, where m is the slope, of course, but the x1, y1, these are the coordinates of a point. Okay? And so we'll literally just plug in, like in this case, if we know that our line is passing through the point 6, 7, then those would be the values of x1 and y1 that we plug in. Okay? Make sense? And then once you plug all that stuff in, I'm going to end up with y minus a number equals, I'm going to plug in a value for slope, some number times the quantity, x minus another number. And then all I have to do is just some algebra. I'm just going to simplify and isolate y. And by doing that, by just doing the algebra, I always end up in that form. Okay, every time. So let's look at one like that. And then we'll maybe just quickly review how you can do it without doing that too. You don't really need to. Okay. So in this case, now write an equation of the line that passes through the point 6, 7 and is parallel to the line through these other 2 points. Now, the mistake people make with this is they confuse the points. Okay? Are these other 2 points on the line that we're trying to write an equation of? No, they are not. They are not. Okay? Exactly. They're only there for us to get a slope. That's it. The blue point up here is the point that we're going to use in our equation. That's the only one, right? That's the only point that we know that our line goes through. These other 2 are just there to give us some information about our slope, nothing more. Now, if our line is parallel to this other line, then what does that tell you about the slopes of the blue line and the red line? 2 separate lines. Say it again. They're the same. Parallel lines have equal slopes, right? So all we've got to do then is we've got to go up here and calculate the slope. I'm going to call this the red line. I've made up different colors so we can keep them straight. Calculate that slope, and that's also going to be our slope. Yes, sir?
Oh, okay.
Oh, go ahead. What do you get?
Okay, subtract -6 from -8.
Okay.
And 11 from 7.
Perfect. Okay, so we're going to set up our rise over run, and so we're going to subtract the y's first. So you're going in this direction, which is fine. You're subtracting these numbers from those numbers. Perfectly fine. So we just have to be consistent. So -8 minus -6 turns into a plus, right? Over 7 minus 11. Everybody agree? Rise over run, change in y over change in x. Now what's that give us? What's -8 plus 6? -2, good. Okay. What's 7 minus 11? -4. Again, you got to make sure you get those signs right, because they make a big difference, don't they? So then, if we simplify that, good. Negative divided by negative gives us a sign of positive, and then 2/4 reduces to 1/2. So our slope is 1/2, good. Now we want our line to be parallel to that, so our line's gonna be same slope, right? And here's our point. Okay, so now let's use this point slope form and get an answer. See it somewhere? What are we looking for? Point slope. Uh-oh. What the heck did it do?
You just copied me.
I didn't want to copy it. Struggling. I am struggling. Is that a surprise?
That one's supposed to go up.
Oh, that's supposed to go up. I got it.
Up.
Here, let me just do this. I'm struggling. Let me undo, yeah. Yeah, I wanted to paste, but I guess I grabbed the wrong stuff. Holy smokes. Well, let's write it again. Let's take it. Jeez. Having some issues here. Okay, so point slope. So we'll start with y minus y1 equals m times the quantity x minus x1. Shh. Okay, so we'll plug in what we know. Good, we know the slope is 1/2.
We know y1 and x1.
Which is
So it's y minus 7 equals 1/2 x minus 6.
Good, okay, our point was 6, 7. Okay, 0.67, so I know that the x value then, there's x1, there's y1, so the 6 goes in for x, the 7 goes in for x1, that goes in for y1, and I end up with y minus 7 equals 1/2 times x minus 6, okay? And then all I've got to do now, it's always the same. To simplify this, what do I do? What do I do with the 1/2?
times it.
Good, okay, I'm gonna distribute and add like terms, and I'm done. It's always those two steps if we're using point slope. So if I distribute the 1/2, 1/2 times x is 1/2 x.
Minus 3.
Ah, good, okay, 1/2 times 6 is 3. Then the last step,
Plus 7.
ah, good. Add 7 to both sides, very nice, and we got it. So we get y equals 1/2 x plus 4. Got it. Okay. Now, did we have to use point slope? No. It works great. It's just as good, but we didn't really have to. We could have also, if we wanted to.
Hey, Mr. Oya.
Oh, whoops.
Hey, well.
Whoops. Okay. Okay, everybody got it? Okay, let me just quickly show you how you can avoid that. You don't necessarily even have to do that stuff. Somehow that got messed up. I don't know how that got so messed up. Okay, we could have just done this. I think this is how you're used to doing it. If we had just said y equals mx plus b, we already calculated our slope. We won't redo all that work. We found out that the slope is 1/2. Right, we have this point up here, so we already know m. We're just trying to find b, correct? How do we find b? Good. Yeah, we plug in the x and y values that we know that work for that are the coordinates of a point on that line, so their solution. Not these, but that one, right? We have to use the blue point because that's the one that the line passes through, so that's a solution. and then we plug in the slope, and then the only thing remaining would be b, so we can solve for it, right? So we would just get, if we did that, we would get
7 equals a half times 6.
yeah, exactly. 7 equals 1/2 times 6 plus b, right? And what's 1/2 times 6? 3. So 7 equals 3 plus b. Last step, subtract 3. B equals 4, m equals 1/2. So our answer is just y equals m 1/2 x plus b 4.
Easy enough.
Easy enough. Okay, so then direct variation. Last little issue. Okay, very, very simple. Direct variation, extremely simple. Direct variation just means that it fits this equation, y equals kx, where k is a constant. It's what we call the constant of variation. Tells you how aggressively y is changing with x. If k were 2, for example, that's telling you that every time, every time x doubles, y is going to increase by twice as much, okay? What this really amounts to, if you think about this, if you take the equation y equals kx, that looks an awful lot like the equation y equals mx plus b, where b equals what?
Y.
How could, no?
No. K.
0, yeah. Notice there is no b, there is no number being added, there's no constant being added to stuff here, so it must be 0. So it looks just like y equals mx plus b, where b is 0, and what's m? K. M is just the number being multiplied by x, so m is just k. In other words, direct variation just amounts to a linear equation. If b is 0, what does that tell you about the line if the y-intercept is 0? Where does it pass through the y-axis? It does, at y equals 0. So it's going through the origin with a slope of k. That's it. If you look at direct variation, that's all it is. It's a simple line that goes through the origin with a slope of k. All right, so the kinds of problems that you're going to see are stuff like this. So given that we have some direct variation going on here, I guess I need to give you the equation, huh? I'll make one up. X and y vary directly. So let's say that when x equals 0.5, y equals 4. How about that? Okay. So first of all, write the direct variation equation. Well, if it tells me x and y, how could I solve for k? Plug it in, sure. If I know that y has to equal kx, if I plug in these values that I know work, that's a solution. If I put 4 in for y and 0.5 in for x, what do I get? Okay, if I divide both sides by 0.5, now how many times does 0.5 divide into 4? 8, doesn't it? Good. 4, that's the same thing as saying 4 divided by 1/2. So I flip and multiply. So I end up with k equals 8. So there's the first part. I can write the equation y just equals 8x. Okay, I know what k is, so now I know what the direct variation equation is. Find y when x equals 23, that's pretty simple. What do I do?
Times.
Yeah. Just plug 23 in for x. Find out what y is. No big
Easy
deal.
enough.
Easy enough. Okay, I think we're good. Let's head down.
Yeah.